Alright, this is the continuation. It didn't take me long to figure out the dumb mistake that I was making here, where if you subtract x over to this side, you don't actually get negative 2x, you get negative 4x. Oops. So that makes this 16, and that makes this 2 plus or minus the square root of 8 all over 2. That's 2 root 2, so that's 1 plus or minus the square root of 2, because I can divide both of those by 2. Okay, so there's the solutions, and that should match up. I still have this in my graph here. And if I find those intersections, calculate intersect, I'll go over to this, closer to this intersection first. There, that's given me 0.586. And the other one, looking for the other intersection, I need to move my cursor over closer to that. That should be good enough. Nope, it jumped back to that one. I guess I need to get closer. So, try again. That better be close enough. And that's 3.414. And I'm not going to check by plugging them in here. I'm going to check by just seeing if my math now supports that. 1 plus the square root of 2. Oh my god. And then 1 minus the square root of 2. Okay, McGrath, what are you doing wrong now? So let's see. What did I do? So opposite of b. Oh, that changed this too. That's the problem. Sorry. So that's going to be 2 there, because that would have been a 4. Alright, so 2 plus, this is my favorite problem. Just kidding. There we go. So there's that one, and then 2 minus the square root of 2. But obviously, we can see the value in checking answers, because it helps us figure out when we're making mistakes. Alright, sorry about that. But there you go. Your math teacher is only human. So, number 77. I got 400 over 1 plus e to the negative x equal to 350. Going to do some algebra here. You know the cross multiplying trick? I'm going to multiply this up to this side, and I'm going to divide this over to this side. Often very useful algebra move. So that's 400 over 350. So kind of like as if this was over 1. I'm just crossing things up. I'm moving this up to here, moving this down to here, multiplying up, dividing down. Okay, so then e to the minus x is equal to whatever. I guess I could reduce that. 40 is 8/7, and then subtract the 1. So that's just 1/7, isn't it? And so then natural log both sides. Natural log of e to the negative x, but the negative x can come outside. That's why I make that move. And then that's natural log of 1/7, because 8/7 minus 1 is 1/7. Natural log of e is just 1, so x is equal to negative natural log 1/7. And just by logarithm rules, you know that that's the same as natural log 7, because this negative, this is like a negative 1, could come in as an exponent and flip that over. So that's the same. You wouldn't have to recognize that, because you could just put it in your calculator as negative natural log of 1/7, and then you could see, I could show you that it's the same thing. Oops, you can't see that if it's off the screen though, can you? There you go. And we could do a quick check on the answer for this one. So plugging it into this side, if I have 400 over, I should use the fraction bar on this one, 400 over 1 plus e to the negative answer. I should get 350. Boom. Oh, you didn't see any of that, did you? There it is. '79, last one from this group. Very similar to that. So the algebra moves at the start. If you had any trouble with 77, maybe you could give yourself another chance to try this one on your own before you watch me do it. Give you a chance to pause. I don't think it's ever a bad idea to remind you that the best way to use these videos is to make them like super interactive, like just kind of chilling and watching me do math. I'm going to do much for you. 40 over 200, when I do the same cross thing, I'm going to get this up here and then the 200 on the bottom. 40 over 200 is 1/5. That's what's happening there. Now I'm going to move this to one side. It's like I'm adding this to the other side and then subtracting the 1/5. Then I'm going to divide by 5. Dividing by 5, that's the same as that 5 becoming part of this denominator. Then I'm going to natural log both sides because I know the natural log of e will just turn into 1. So when I natural log both sides, have we done this enough times yet that I can just go straight to that? Maybe? It's like I skipped writing this step, right? Because I knew the natural log of e was just going to turn into 1. And then I just need to divide by negative 0.01. So my answer should be whatever natural log of 4 over 25 divided by negative 0.01. Whatever that is. Let's find out. Natural log of 4 over 25 divided by negative 0.01 is 183.258. I wrote that down off the page there. See? And could do a quick check on that. I'm going to bring up a little fraction. Got 40 over 1 minus 5 e to the negative 0.01 x. Oops, not x. Answer. And that should give me 200. Yep. Okay, moving on to the next section. We got number 91. We're now solving log equations. So instead of taking the log of both sides, we're going to turn logarithms, we're going to like rewrite them as exponentials. So for example, this is a very easy one. Natural log is log base e, so that means that's the same as e to the negative 3 is equal to x. Right, so once I get it as a single logarithm, I can just rewrite it like this, and then I can just jam that into the calculator if I wanted to know the decimal answer. I think, yeah, they're going to have the 3 decimal place in the back of the book, so you can do that if you want and check to see what they have in the back, but that is the exact answer, e to the negative 3. For 93, same idea. So natural log is log base e. That means e to the 2.1 is equal to 4x. So x is equal to e to the 2.1 divided by 4. Number 95, log base 5 of 3x plus 2 is equal to log base 5, 6 minus x. Well, this is a little bit different logarithm rule. This is just the rule that says if you got log base 5 of thing equals log base 5 of thing, then those things have to be equal to each other. Kind of obvious. And then that's just like a baby algebra 1 problem. So x equals 1. The check of that, you just plug 1 back in here. That gives you 5 and 5. So obviously that's right. Number 97, negative 2 plus 2 natural log 3x equals 17. So a little bit of algebra first. Going to add that 2 over here and then divide by 2. So adding the 2 over here gives me 19, and then I'm going to divide by 2. That's just like baby algebra stuff. And then, to get rid of the natural log, well, natural log is e to the this equals this. So 3x is equal to e to the 19 over 2. That's a move, I mean, that's like the move that we're learning, right? One of the moves that we're learning. That's the thing that you just need to practice to get comfortable with. Then x is equal to e 19 over 2 divided by 3. Well, and we could check that one, maybe, just to do it on this side and see if we get 17. So let's see. Negative 2 plus 2 times the natural log of 3 times our answer is 17. Sure enough. Right. 99. Where are we going to? Number 111. We're getting there. 99 is 7 times the log base 4 of 0.6x equals 12. So a little bit of algebra first. Log base 4 0.6x is equal to 12 over 7. And then this is a different log base, so this is now 4 to this power is equal to that. So 0.6x is equal to 4 to the 12 over 7. So x is equal to 4 to the 12 over 7 divided by 0.6. I would not try to get decimals or anything along the way. I would just leave it like this because that's no problem for our calculator, right? 4 to the 12 over 7 all divided by 0.6. You know, you pick and choose the ones that you check. This is a pretty, well, actually this one's not that easy to check because I'd have to do a change of base thing. Do I want to do that? Sure. Like, well, do you want me to do that? Okay, I'll do it. So to do this, to check it with a calculator, our calculators don't do base 4, log base 4. They do log base 10 and natural log. So I have to do a change of base thing on this, which means recognizing that this side right here, that's the same as 7 times log. You can use common log or natural log here. I'm just writing it as common log over log 4. So this right here turns into log 0.6x over log 4. So now we could check it. We could check that and see if that gives us 12. So let's try. 7 times log of 0.6 times our answer over log of 4 should give us 12. And just to show you that it would have worked with natural log, you want to use natural log instead? Sure. Just do 7 times the... Oh, it's not, now my answer thing isn't going to work though, because, hold on, maybe if we do this, let's go back in here. No, because it's going to copy that, it's not going to let me. Yeah, take my word for it. If you had entered it like that, you'd get 12. You can try it if you want. But I'm done with that one. I'm moving on to 101. Got log base 10 of z minus 3 equal to 2. Well, I'm going to rewrite that as the exponential, so that means that z minus 3 is equal to 10 to the 2. And I can do that without a calculator, because 10 squared is 100. I'm going to add 3. So 103. And log 10 is, that's common log. That's like our log button. So that would be easy to check. Well, actually, there's nothing to check there, because log 10 of 100 is obviously, yeah. That checks out. Don't need the calculator to see that that's right. Natural log of the square root of x plus 2 equals 1. All right, so let's see what we got here. Natural log is log base e, so square root of x plus 2 is equal to e to the 1, to e. I'm going to square both sides. You got to watch out. Is when we square both sides of an equation, we introduce the possibility of answers that don't actually work in the original problem. So in problems like this where you're solving for things inside logarithms, you really do want to check the answers, make sure that they're actually going to be positive numbers. Sometimes you get negative answers. This one looks like it's going to check out just fine, but let's make sure. So e squared minus 2. This is just a situation, especially when you get two answers. It's often the case that one of them is going to show up as a negative number inside a logarithm and be like a bogus answer that does not, in fact, work. Okay, so there's my answer. So I'll just do a quick check here to see that natural log of the square root of answer plus 2, does that equal 1? It does. 5.389. 105. A couple things that you could do here. You could bring this out to the front first if you wanted to. Like, oh, I know a logarithm rule. Cool. And then divide both sides by 2. And that means x plus 1 has to equal e to the 1. So x is e minus 1. Other way to do it would just be to be like e right here, rewrite it, like x plus 1 squared is equal to e squared. And then you take the square root of both sides. When you take the square root of both sides, that would give you like a plus or minus here. But this is like, if you had done it this way, then you get two answers. X is equal to positive e minus 1 and negative e minus 1. But this one doesn't work because you get a negative inside your logarithm. Oh no, wait a minute. Does it work? Hold on. Maybe they do both work. Maybe bringing this out actually loses one of the answers. Hold on, let's not scratch that out. Let's actually check them, because that's the right thing to do. Check your answers. I think they're both going to work. So e minus 1 is 1.718, and negative e minus 1 is negative 3.718. So I'm just typing that in, so that's my answer now, and then I'm going to check this. So natural log of answer plus 1 squared is 1. What? Why did I get 1 instead of 2? What happened there? Hold on. Give me a second. Oh, I wonder if it's an order of operations thing. It might be because of the way that I entered this. That's interesting. So maybe it's because I want to make sure that I'm doing the natural log of my answer plus 1 squared. I think that's the problem. Yeah, that's interesting. Okay. Well, be careful. Make sure that when you have something like that, that the entire thing is inside the logarithm. I guess it's the moral of that story. And then I could check my other one, negative 3 point. This is the one I was worried about because it's negative. I'm going to type that in, so that's my answer now. And then I just go back a couple entries. Entry, entry. That's the thing I want to check. And that's also equal to 2. So we actually lost an answer if we did it this way. But there are 2 answers. A little bit tricky. If you're wondering to yourself, wait, can I do the graphing thing for these? Like graph both sides of the equation? Yes. But it is up to you to have a graphing calculator and know how to do that. I can certainly help you with that, but I cannot give you a graphing calculator. Did you know if you look in the RCHS, the program of studies, like where all the different classes at the high school are listed, it does actually say that you having a graphing calculator is a requirement for this course. How about that? It's a tough requirement to enforce because they're not cheap, like $130 or something down at Wally World. Sometimes you find used ones on the internet for much cheaper than that. Talk to me if you're in the market for one. All right, so here I use the subtraction turns into division logarithm rule, and then I'm just going to use the definition. I'm going to rewrite this as the exponential, so 4 to the 1/2. 4 to the 1/2 is 2. That's 4 to the 1/2 power is square root x over x minus 1 is equal to 2. And then I'm going to do algebra. I'm going to multiply that up there. So that's 2 times x minus 1. I'm going to distribute the 2. That's me multiplying that up to that side. Then I'm going to subtract an x here and add the 2, so x is equal to 2. And then this is a logarithm thing. So I think I'm going to be okay because when I plug 2 in here, I get a 2 and a 1. I get positive numbers inside my logarithms, so it should be good. Oh, and I can't check this one either because change of base, but let's see. We can just manually check it. If this is a 2, and I plug the 2 in here, then log base 4 of 2 is 1/2. Log base 4 of 1 is 0, so that it does check out. Alright, kind of similar looking thing here in 109. Definitely, again, going to be a check the answer. Just make sure that all these come out to be positive. So, going to consolidate on this side. Subtraction turns into division. Inside one logarithm, x minus 1 over x plus 1. And then the logarithm equals logarithm, so these insides have to be equal to each other. So x plus 5 equals x minus 1 over x plus 1. Okay, algebra time. So I'm going to multiply this up to here, and then I'm going to FOIL those out. That's x squared plus 6x plus 5. And then on this side I have the x minus 1. That's me multiplying this up to this side and then doing the algebra to expand that. And then I'm going to subtract my x. And I'm going to add this 1. And that does factor, doesn't it? So that's x plus 2 and x plus 3. Because 2 times 3 gives me the 6, and that combines up to give me the right middle term. So x equals -2, and x equals -3. But I can't take the logarithm of a negative number. So any solutions that give me negatives inside the logarithms are bogus, and I think it looks like both of them do. So I think we got a no solution situation. Because when I check the -2, that's fine, but that's a negative number, and that's a negative number. That's no good. And here, same thing. That's fine, but these are both negative. So, bust. If you're wondering, I'll show you, what would that have looked like if we had approached that with the graphing method. So with the graphing method, I would have graphed one side of the equation, natural log x plus 5, and the other side, natural log x minus 1 minus natural log x plus 1. And then I'm just going to make sure I'm in my standard window. I'm going to go zoom 6 for that. So you can see, this is where, if you're wondering what's going on there, that's where that vertical asymptote would be. The calculator doesn't know how to draw those. So this is it coming up here, and this is this one coming out here, and then they never cross each other. So there are no intersections, no solutions. Happens. All right, that was number 109. And we got, do we have only one more left? 111? Oh, I can squeeze it onto that same paper. Do it up here. 111. Last one. Got log base 10 4x minus log base 10 of 12 plus the square root of x is equal to 2. Going to combine these using the subtraction turns into division property. That's 4x over 12 plus the square root of x equals 2. And then I'm going to rewrite this, turn this into an exponential. So this expression here is equal to 10 to the 2, also known as 100. So then I'm going to do some algebra. I'm going to multiply this up to that side. So I get 4x is equal to 100 times multiplying 12 plus the square root of x up here. And then, let's see, there's no great way of dealing with this, I think. I would not be asking you to do this without a calculator. There's a way of doing this, of like squaring both sides to try to get rid of this, but this is a plus here, so like you have to FOIL this out, so you want to get yada yada yada. I think from here I'm realizing that I probably just want to use the calculator, and if, I don't know, if we're going to use the calculator, we could use the calculator on the original, but I'm going to use it on this, and then I'll check my answers with the original. How about that? So I'm going to do the graph both sides technique. 1200 plus 100 square root of x, and I think I'm already in my standard window. That's a good place to start. There's 4x, and then this 1200 plus 100x, that's off the screen. And maybe at this point, looking at that, well, we could try to sort of guess what the solution would be. I mean, my recommendation would be go into the window. We're not going to be looking at any negative numbers, so I'm going to make my minimums equal to 0, my x min and my y min equal to 0, so I'm only looking in the first quadrant. And 10 and 10 didn't get it done, so I'm going to add zeros to those. What about 100 and a 100? Still not enough, so I'm going to go back to the window, and not going to make it 200 and 200. I'm going to add zeros. I'm going to go up by powers of 10. Still not enough. Go back to my window. I mean, that's already bigger than 1,000, so it's not super surprising that I haven't seen the solution yet. Maybe this is going to be the one. There it is. So, looking for the intersection, intersect, first curve, second curve, boom. So it's at x equals 1,146.5. That's my intersection. And this is a logarithm problem, so I should check that answer. So 1,146.5. Put that in so the calculator thinks that's the answer. And then this is log base 10, so I can check easily. Log of 4 times the answer, calculator thinks that's the answer, minus log of 12 plus the square root of the answer. That should be equal to 2. Boom.